Hello, this video is going to show how we can achieve functional safety using the Cypress PSoC Creator. Now, there are a number of different boards that I could use, but the one I've got connected to my laptop at the moment is a PSoC 5, and this has a Cortex M3 core. Now, the starting point is the PSoC Creator, and inside here I've created a number of projects, but the one I'm interested in is this one here. So first of all, I've got a very simple top design. I've basically just added in a UART, and that was in case I want to be able to get data off the target using a serial port. I've generated the code from my design, and here we can see the generated code. Now, I'm not particularly interested in this code. What I am interested in is the code that I've written myself, and here I've got two simple files, and what I'd like to be able to do is to take a look at this code and see, first of all, is it compliant to a coding standard such as MISRA C 2012? I'd like to be able to look at the quality of this code and see, well, is it too complex? I'd like to be able to measure various metrics on it, like the cyclomatic complexity. Then I'd like to be able to execute the code on my target, and as it executes, I'd like to be able to find out, well, how much of that code have we actually exercised? And then finally, I'd like to be able to do some unit testing on this code in order to ensure I've got the full coverage. So first of all, let's check we can build the project. So let's go and do a clean and a build. So that's now going to start regenerating the code, and now it's building it with the GCC compiler, and that's now built. So what I'd like now to be able to do is to start to analyze this code. So to do so, I'm going to go to the LDRA launcher, and I'm going to start the build import. And inside here, I'm going to run exactly the same build as what we just did, but this time we're going to listen to what happens, and we're going to be able to get a list of all the source files, the include paths, and the defines. So there we can see the GCC compiler, and that's now generated two projects. So we can see it's generated a library and also an ELF file, whereas this is the one I'm interested in, and this is containing the two files that I've written myself. I can take a look, I can see the include paths, I can see the preprocessor symbols. So basically, I've got everything I need now in order to be able to analyze this code. So I could now open that project inside TB Vision. Well, to save time, I've already done this, and here is the project. So let's see, is this compliant to MISRA? Let's do a code review, and we'll take a look at the results. And it wasn't written to be compliant, and so we have a lot of violations. Let's double click on one of these violations, and that will now open up my editor, and it's taken me to the place where that violation occurs, and that's very easy to fix. I just need to put a U in here. Well, I'll do that later. What about the quality of this code? Well, let's take a look at a system call graph. The system call graph is showing us all the functions, and we can see how they're interconnected. I can view this in various different ways. I can view various different metrics, like ones that give me an idea of clarity, and ones that give me an idea of testability, and here ones that give me an idea of maintainability. And one of the most important metrics is probably the cyclomatic complexity, and I can sort and find the most complex function, that is this one. Well, let's take a look at this in a graphical way using a flow graph. And there we have the flow graph for the function. If I click on this block of code, we can see the corresponding block over here. If I was to click on this particular block, we can see the corresponding block over here. If I wanted, I could click on a branch, and I can see this is the branch from here down to there. Okay, so what I'd now like to be able to do is to execute this code and find out how much coverage can I obtain by executing it. Well, my main is just going to, let's take a look at the main, and as we can see, it's just going to call a function a certain number of times. So let's go and perform what we call the dynamic analysis. This is going to instrument the source code, and then it's going to perform the build. So there we can see it's building now with the instrumented code, and then it's going to start executing it on the target. So there we can see we're erasing the target, we're programming it, and then it's going to start executing, And in this particular case, we're going to be using GDB to control the execution. If I wanted, I could actually get the data off the target using a serial port. So that's now executing, and it should get to the end. And now we'll be able to analyze the history and find out, well, what parts of the code have we just exercised. So we'll go back to the system call graph, and this time we'll put it into a mode that shows us the coverage. So green is showing us we've got full coverage, red we haven't got the full coverage. So we can see integer to ASCII, we've got 76% statement coverage. Well, we could view that graphically on the flow graph, and this time we've colored the flow graph green to show us the paths we've taken, and red the paths we haven't taken. So some branches we haven't taken, but also we have 4 blocks here that we've not executed. Why not? Well, it looks like we've never had a value less than 180. So if I want to get coverage for this, I could use the unit testing tool tbrun. So let's open tbrun. Okay, so inside tbrun it may need to do a little bit more analysis. And now let's go and open a sequence of test cases that I've previously created. So I've got them inside here. So there I'm opening that sequence of test cases, and let's run these on the target. So that's now generated a harness, it's built it, it's now downloading to the target, and this is going to take quite some time to execute. So while that's executing, let's take a look at some of these test cases. So we'll just wait for that to start running, and now we should be able to go and take a look at some of these test cases. So here we can see for this particular test case we've got a number of inputs and expected outputs, and all of these are slightly different. So in this particular case we have 8 digits, and we can see the expected output for a value of 0 should be all zeros. In this particular case we've got a value that's less than 180, so that should exercise the part of the code that wasn't executed earlier. So with this we're expecting to get the output of character 1, character 2, character 3, and then all the zeros. Okay, well let's just wait for this to finish. Okay, well that's finished, and the good news is all the tests are passed. So with these inputs we got the expected outputs here. And we should now be able to also take a look at the coverage for our integer to ASCII function. And now we can see with these tests we've got 100% statement, 100% branch, and 100% MCDC. Okay, so hopefully that's given you an idea of how we can achieve functional safety using the PSoC Creator. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.